Okay, so today we're going to go over target number 4 from the test 12000. Okay, so a rabbit is on the number line starting at 1. Every minute, the rabbit hops 1 unit to the left with 60% probability or to the right with 40% probability. However, if the rabbit ever reaches 0, it is sent back immediately to 1. What is the expected number of minutes it will take for the rabbit to reach 4? And express your answer as a common fraction. Okay, so before we go into the solution, I just want to introduce a few concepts that will help us answer this question. Okay, so the first one will just be expected value because that's what we need to find, right? So before we find it, we want to know what it means. Expected value is calculated as the sum of all possible values multiplied by the probability of its occurrence. Okay, so in this case, we want to find the expected value after jumping to the left, multiplied by the probability, which is 60%, or in this problem, we're going to use 3 over 5. And then we add it to the expected value after jumping to the right, times 2 over 5. Okay? So we're going to go over that more in depth when we look over the equations. And the second thing is we're going to involve 3 states, or we can just consider them as variables called E1, E2, and E3. Each of these states or variables represent the expected value of minutes it takes for the frog to get to 4 from 1, 2, and 3 respectively. So for example, E1 is the expected number of minutes it takes to get to from 1 to 4, and which is exactly what we want to find in this problem. Okay? So how are we going to use these 2 facts? What we're going to do is we're going to create a system of equations relating all 3 of the states together. And then that's going to allow us to solve for each variable. So I wrote the first equation down here below, and it's relating E1 in terms of the other variables. So E1 represents the expected value of minutes it takes to get to 4 if you start from 1. So let's consider the 2 events that could happen. So with 60% probability, or 3 over 5, we could jump to the left. However, we know if we jump to the left, we're going to go to 0, and then that's going to send us right back to 1. So after we jump to the left, it's still going to take us an expected E1 steps to get to 4, because that's how many minutes we know it's going to take to get from 1 to 4. However, we have to have a plus 1 in this term, just because it took us 1 jump to get there. So we already jumped left, and we have to account for that. And then the second term is similar. There's a 40% chance or a 2/5 chance that we jump to the right. And that's going to let us get to 2. And then from 2, we expect it to take E2 minutes to get from 2 to 4. Okay, and then there's another plus 1 accounting for the jump that we made to get to 2. And then if we just simplify the algebra a little bit, we're going to get E1 is equal to 1 plus 3/5 E1 plus 2/5 E2. And then if you want to try and find the other 2 equations, I'll give you a minute to pause. But if not, I will just go on to the next slide. Okay, so here's the next slide showing all 3 equations, okay? So the first equation, the top equation, is the one that we saw in the previous slide. And then I'll just quickly explain how we get the other 2. So E2, the expected number of minutes it takes to get to 4 if we start at 2. There's 2 possibilities, right? So 60% chance or 3/5, we jump to the left, then we'll be at 1, right? So then we'll still need E1 minutes to get to 4. And then if we add 2/5, that's a chance we jump right, and then we'll be on 3. So it'll take E3 plus 1 minutes to get to 4, basically. And then if we just simplify the algebra a little bit, we'll get 1 plus 3/5 E1 plus 2/5 E3. And then the final equation, it's similar. It's the same process as the first 2, but the last term is a little different. The first term is still the same. If we jump to the left, it's going to give 3/5 chance times E2 plus 1. However, if we look at the second term, in the 40% chance that we jump right, the frog will stop because it already reached its destination and it will not jump anymore. So it only takes 1 jump from 3 to get to 4, in which it will stop. And then if we simplify that a little bit, we'll get 1 plus 3/5 times E2. And then if we notice, we'll have 3 variables and then 3 equations relating them. So that means we can solve for each of the variables. Now, you can basically use any method here to solve the system of equations. It's a little messy, so I'll just go over it quickly on the next slide, but you can use any method. This is not the only correct way. I'll just go over this work real quick. So if we look at the first equation, we can isolate E1 and E2 to get E1 is equal to 5 halves plus E2. And then we do the same thing with the second equation. We can get E2 in terms of E3 by substituting what we got for E1. So we'll get E2 is equal to 25/4 plus E3. And then if we substitute the values for E1 and E2 into E3, like into the final equation, we can get an equation only E3, which allows us to solve for it. And then what we get is E3 is 95/8. And then we can use the previous two equations, like E2 is equal to 25/4 plus E3. And then we can get E2. And then with the final equation, we can get E1. And the E1 is the answer that we want, because that is the expected number of minutes it takes to get to 4 from 1. And the answer is 165/8. Thank you.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.